Hi, this is Trent Ford. I'm the Illinois State Climatologist at the State Water Survey, part of the Prairie Research Institute at the University of Illinois. And today I'm going to talk about changes in precipitation and precipitation variability across the U.S. So, the large topic here for this workshop and for follow-up meetings is the non-stationarity of the climate, what it means for drought. And often when we think about non-stationarity, we think about the trend, the overall trend in precipitation. Is an area getting wetter? Is it getting drier? But another important piece of non-stationarity is the variability. Is the variability changing? Do we see, as this figure shows on the right-hand side, a shift in the variability to either more variable precipitation on hourly, daily, monthly, yearly, or decade timescales, or are we seeing less or overall more variability? So we need to really consider non-stationarity both in the forms of a trend, the wetting and drying trend, and the variability when it comes to drought. Also importantly, seasonality is not necessarily a distinct form of non-stationarity, but the seasonality in both the trend and the variability of precipitation are really important factors when it comes to drought impacts. So if we see a wetting or drying trend, a more variable or less variable trend, is that happening in the winter, in the spring, in the summer, in the fall? What are the impacts that come from that? And what are the metrics and the indices we need to use to try to monitor and assess that? So I'm going to start here looking at the overall trend in precipitation. The much of the figures that I'm using for this presentation is coming from the fourth National Climate Assessment, which was published in 2017. The reason being is that the National Climate Assessment and assessments in general take in sort of and summarize the body of literature on precipitation change across the U.S. in this case. So it can give us a more holistic view of the change and the confidence in, especially the projections of change in the future, more than just any single study. So what these maps here on the right-hand side show are changes in total annual precipitation on the top, and then each of changes in precipitation in each of the four seasons on the bottom. And what we can see here overall is kind of general spatial patterns in annual precipitation, where the drying trends in the west and the southwest, wetting trends or increases in precipitation in the plains, the Midwest, and the Northeast. However, when we break it down by season, we do see large seasonality in these changes. So, for example, there are places in the country, the Southwest in general, for example, where we see drying in all seasons as part of the Southwest, and in contrast, parts of the Midwest and Central Plains are actually wetting or increasing precipitation in all seasons. But of course, we see areas where there are seasonality or seasonal differences. So, for example, we see a summer drying but a fall wetting trend in the Mid-Atlantic. And so, what does that mean for drought and drought impacts for example, water resources when we have a summer drying trend but a fall wetting trend, and a similar thing in the northern plains, where we have a sort of slightly drying trend in the winter, but a strong wetting trend in the spring and the fall. So not just the overall trend of yes, we're getting wetter, yes, we're getting drier, and in fact, when we look at total annual precipitation, there seems to be a split between Western U.S. and Eastern U.S., but also the seasonality and what that means for drought impacts. Now, as far as projected changes are concerned, and these are projections through the end of this century, as part, again, of the fourth National Climate Assessment. Anywhere you see greens, that's where the models are projecting a wetting trend or getting wetter. The oranges, the browns, are a drying trend. The stippling, those little dots there, what those are showing, the different maps are areas where there's consistency in the sign and the strength of the trend, either wetting or drying, between the models. That gives us a bit more certainty or confidence in those kind of projections. So what we see overall is somewhat robust projected increases in winter and spring precipitation across much of the northern U.S., really from Alaska all the way up to Maine. And that's something that we see in the historical period as well, the last 100 years. So that's really showing, that historical change being projected through, if not intensifying through this century. We also see projected drying in the summertime across much of the U.S., particularly in the Southwest, the Northwest, and the Central Plains. However, the lack of stippling there suggests that there isn't as much consistency or robustness in those projections. A lot more internal variability that kind of increases the uncertainty in those projections relative to the projected wetting trends, for example, in the winter and the spring in the northern U.S. And overall, when we take these projections here, what we're seeing is that much of the historical change, much of the change we've seen in the last 100 years or so, is projected to continue and if not intensify through this century. So that kind of that kind of broad scale drying trend in the west, wetting trend in the east, that is projected to continue. But as I mentioned, that's really only one form of that non-stationarity. The variability and the seasonality of that is really important. So, having 10 minutes to discuss all precipitation change and variability across the U.S. is challenging. So really, I'm going to focus precipitation variability here on heavy precipitation, a very heavy rainfall. The maps on the right, again, from the fourth National Climate Assessment, showing four different metrics of assessing changes in the frequency and intensity of heavy precipitation. Anywhere you see greens and blues, that's where we're seeing an increase, meaning an increased risk of heavy precipitation, whether it be through frequency or intensity. The yellows, the few regions that are shown in yellow are decreased. What we're seeing overall is an observed increase in heavy precipitation frequency in most U.S. regions. Now, it is true that the largest increasing trends are in the Midwest and Northeast, and those are two regions that have consistently stuck out as having increases in both overall precipitation, a wetting trend, but also more intense precipitation. And I'll talk about what that means here in a second, kind of practically, what being in a wetter overall climate, but having more precipitation variability and heavy precipitation means. But also interestingly, for some of these metrics, we're also seeing an increase in heavy precipitation in areas that are otherwise drying. So parts of the West and Southwest that have a drying trend overall are maybe somewhat paradoxically seeing an increase in heavy precipitation. And so, what does that mean when it comes to drought impacts? Is really important when we're thinking about, yes, we're drying, but we're also getting more variable as far as our precipitation. So, I wanted to kind of, for a lot of this talk, bring this down to think about this. What does this mean practically for drought monitoring? And especially when we have heavy precipitation, and what that does for representing or assessing drought impacts. So I think a good example, and one that I'm quite familiar with, is this last summer in the St. Louis, Missouri area. So what I'm showing here is a plot of accumulated precipitation in St. Louis from June 1st through August 31st, kind of the meteorological summer there in St. Louis. And what we see is last summer it was wet in St. Louis overall. It was actually the sixth wettest summer in St. Louis on record, and their records go back to the mid 1800s. But what we can see there from that green line of that precipitation accumulation is that 2/3 of the total summer rainfall came in just 2 days. And in fact, when we break that down even more, it came in just a handful of hours. So when we look at kind of accumulated sort of, especially precipitation based indicators like SPI, or maybe even throwing in evapotranspiration, we think about the SPEI at 30, 60, 90-day levels. When we look at this summer, it's wet. It was a very wet summer. It was the sixth wettest on record. Everything looks wet. However, when you get the majority of your precipitation in just a short period of time, we know that most of that is not being returned to our soils. And in this region, not a whole lot of reservoirs for water availability. It's mainly soils and groundwater. So we're not getting that return. We're mostly getting runoff, a spike in stream flow, and then we're sort of back in conditions where we were in a short period of time. And you can see here on this precipitation graph that leading up to late July, St. Louis was in a 3 to 5 inch precipitation deficit. We're actually talking about maybe suggesting abnormally dry or moderate drought conditions at this time before they got that big rain event that flooded the city out. So, I contrast this by saying, okay, yeah, sixth wettest summer on record, and again, some of these indicators of drought showing, hey, everything looks good, with the soil moisture. Which is another sort of maybe integral sort of indicator of drought. So despite the fact that the summer was the sixth wettest on record, we spent the 8-inch soil moisture here measured at Belleville, which is in the kind of the eastern part of the St. Louis metro area here in Illinois. The 8-inch soil moisture spent 2 full weeks this summer below the percentile threshold for what would be considered moderate drought, moderate soil moisture, moderate agricultural drought. That's that black dashed line there. And what we can see here is that consistently dry conditions in June and most of July led soil moisture to drop from near to above normal conditions at the beginning of June, all the way down to anywhere around 20 to 21% volumetric water content, which is not far from our wilting point. And really below that 26% volumetric water content, that's the sort of historical 20th percentile for this time of the year. We are in by statistical measures, moderate drought. And then you can see the spike there from the big precipitation event. But then because much of that went to runoff, not really recharging the soil, especially on the deeper layer soil, we had a consistent nosedive of soil moisture again. So we went drought and then had this heavy precipitation event. Depending on the indicator you're looking at, we could say, hey, we're good. In fact, we're probably good for months because we got 2 or 3 months worth of precipitation in just a number of hours. But in reality, with some of these impacts that are maybe more tightly coupled with soil moisture or vegetation, we're not seeing that same kind of recovery. So this is where more intense, heavier precipitation, more variable precipitation can really make a challenge for drought monitoring, even in a climate that's getting wetter. So for projections or future changes of heavy precipitation, that's what these maps are showing again from the National Climate Assessment, the fourth National Climate Assessment. And overall, what we see is just blue and positive numbers. So overall projected continued increases in heavy precipitation, both frequency and intensity. However, I will say that even more so than the trend part of non-stationarity, when we think about wetter overall or dry overall, there is considerable uncertainty when it comes to projections of precipitation extremes, mainly because precipitation extremes are generated by smaller scale systems, mesoscale convective systems, individual kind of pop-up thunderstorms that are challenging to model both at the spatial scale of climate models, but also out decades in time. So there is considerable uncertainty with that, but the consistency across the U.S. in the projections of increased heavy precipitation, increased precipitation extremes, and even under lower emission scenario is somewhat striking. Okay, so a summary here, and I like to put my summary slide by, again, contrasting. I used the example from St. Louis from last year, but even just this year, what does it look like when we have a state like California, which, as of kind of the beginning of the year, had something like 15%, or I guess about 15% of their drought of their region in exceptional or extreme drought. When we have that much drought covering a state, at the same time, a state that's getting an area that's getting, 150 to, in some cases, 500% of normal precipitation over the first 2 weeks of the year, what does that look like with changing variability, right? And again, that really kind of harkens to the questions of what indicators are we using to talk about drought, going into drought, staying in drought, and coming out of drought, both in drying climates and in wetting climates. So kind of summary points here: drought non-stationarity should include both the trend and the variability. We're seeing for the trend somewhat divergent trends across the U.S. the past 100+ years. Historically, generally wetter east, drier west, and in general, projections are sort of showing that into the future as well. We see increases in heavy precipitation nationwide, both in drying climates and in wetter climates, which is interesting. And that is, given the projections, likely an issue for the foreseeable future. And just to kind of the point I try to make here is that changing variability and seasonality really require a diverse suite of indicators for impact monitoring, assessment, and prediction as we move forward.